Welcome to the channel Knowledge Star, Continuous Knowledge Excellence. My name is Nisha Masroor. In this video, we will get to know about visual detection of AFP marker and detection sensitivity. Now, our expert Professor Himadri B. Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Teledicon Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobio-interface science, soft matter science, polymer physics and biophysics. We'll explain you in detail about this topic. So, to get complete information, watch full video without skip.
This is the structure of the different alkanols I talked about. This is the sulfur group here. This is 2 carbon atom system, mercaptoethanol, 2Me is written there. And the beauty is this molecule binds very beautifully to gold because this is a very strong electron releasing ligand. It both binds to gold 1 and gold 3. Okay, now the protocol for detection is extremely simple, it is described here. So these alkanols are added to gold solution in this medium, glycine and sodium hydroxide medium at pH 10, and then they get adsorbed on the surface because of the gold sulfur linkage that is formed. Then various things happen when you mix with the analyte. When you see this spectra of this material, this mercaptoalkanol, they have got 2 distinct peaks. One is 650 and one is 520 in presence of gold. Now, if you take the intensity of absorbance of the peak at 650 and 520 and take the ratio of that becomes a very good indicator of what we can call the signal strength. Okay, so this is the absorbance 650 divided by absorbance of 520 nanometer, the ratio, and that is plotted as a function of the alkane thiols here. This is basically the mercaptoalkanol family, also called alkane thiols. And you see that for A, which is 2Me, with the ethanol, the signal peaks very nicely here at a particular concentration, so it makes it detectable. For others, 4 and 6, the signal is really very high after a certain concentration, so it makes it detectable. And D is not really an excellent partner here, binding partner, so that you don't need to discuss about D here. It's intermediate here. So both B and C and A are good binding partners. So within B and C also we should choose only B. There is no need to go to a longer hydrophobic chain. So mercaptobutanol is the candidate, followed by mercaptoethanol. These are the 2 selected ligands that we are going to use. Now, what is how the selective probing of this heavy ions take place here? Now you see, when you take the butanol, mercaptobutanol at the ligand, look at this figure here. This is the gold nanoparticle. You add the 4MB molecule to this. This is the thiol group there. Then they get coated on the surface of the gold nanoparticle.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
And then they form a cluster like this because hydrophobic interaction is there, and you have a very nice cluster aggregated structure of gold nanoparticles there. Now, when you add mercury to this, or put it in a solution containing mercury ions, then the thiols, they bind selectively to the mercury and they leave the surface of the gold nanoparticle. So then they make a complex of mercury sulfur bonding is there, and they are separated from the gold nanoparticle from surface. Some amount of gold nanoparticle is still coated with the alkane thiol here, like 4 MB. But this has resulted in the disintegration of this aggregate. So after you add 4 MB, the solution will have certain color like this. And then you add mercury to this one, the color will change because the aggregate has dispersed. This is the story for detection of mercury. Now, if you go to the detection of lead, silver, and copper, this just the reverse happens. The binding ligand is 2Me, mercaptoethanol. They, as before, they bind nicely on the surface of this thing, and they don't really, because the hydrophobic group is shorter, the hydrophobic interaction is very, very weak compared to this one. So therefore, this is not strong enough to hold an aggregate. So they will not form an aggregate. The individual coated nanoparticles will remain separately in dispersion. All right. Now add any of these metal ions, lead, silver, or copper. Now the lead, silver, and copper will immediately, as before, they'll form a complex with 2Me, but this complex will still stay on the surface of the gold nanoparticle, because the charge on the surface of these are all positively charged, and gold nanoparticle has a negative charge surface. So that will come and sit on the surface, electrostatic binding, and the tails will be extending out, which is the hydrophobic part of it, and then they will form a nice cluster here. So this is a balance between electrostatic and hydrophobic interaction that is giving rise to the cluster formation. Compared to this, in this case, the hydrophobic forces are much, much stronger. Okay, so they formed the cluster earlier, but secondly, when they formed the complexes with the 4MB, these did not stay on the surface of the nanoparticle any longer, though they had different electrostatic charge, because the hydrophobic interaction is actually very strong here. That will not allow it to stay there, and that hydrophobic repulsion between these two things will also take it out. So no cluster formation will take place, whereas for a smaller hydrophobicity, the cluster formation will be favored in this case. And that will change the color of the material and giving rise to seeing the color change, and consequently, you are able to see or observe the sensing.
I hope you like this video. Here, I would like to give you an important information that Nanoscience and Technology Consortium, or NSTC, organize the nanotechnology workshops on very interesting topics. Also, I would like to tell you about the initiatives of NSTC, in which you can also be a part of, like mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. So that's all. If you want to see these type of videos, then please do comment. We will definitely reach out to you. Subscribe to the channel Knowledge Star and hit the bell icon to never miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.